Let's start by looking at another way to handle sequences. Here we have the sequence u sub n, and it gives us u sub 6 equals 57 and u sub 10 equals 93. Then it's telling us to find u sub 1, a recursive formula, and an explicit formula. Just to review, a recursive formula is u sub n equals u sub n minus 1 plus d. That's our common difference in the term before. The explicit form, u sub n equals, and it's u sub 1 plus n minus 1 times d. For this one, we have a problem. We don't have a common difference, and we don't have a u sub 1. So we're going to have to find our u sub 1, and before that, we have to find our common difference. Here we have u sub 6 and u sub 10. This is the 10th term in the sequence and the 6th term in the sequence. So if I'm trying to find my common difference, I can take their values, 93 minus 57, and divide that by the difference between the two of those, divided by 10 minus 6. So 93 minus 57 is going to give me 36 over 4, and that gives me a common difference of 9. Now I can work backwards from my u sub 6 to find my u sub 1. So if I go back 9, that's going to give me 48, and u sub 4 equals 39. U sub 3 is 30. U sub 2 is 21. And u sub 1 is 12. So I have my u sub 1. And now I'm going to write my explicit formula out. U sub n equals u sub 1, which is 12, plus n minus 1 times 9. How can I check to see if this works? Well, I can check my u sub 10 because I already know what that is. U sub 10 equals 12 plus 10 minus 1 is 9 times 9. 9 times 9 is 81. 81 plus 12 is 93. My u sub 10 is correct. I know my explicit formula is correct. Now I just have to write the recursive formula. And that's even easier. U sub n equals u sub n minus 1. That stays the same. Plus my common difference, which is 9. And that's my recursive form. So it's really the same thing, just a different approach, different type of problem. On a new topic. This is within sequences, but it's summation notation. Sometimes you have to find the sum of various terms in a sequence. So I'm going to walk through what our notation actually means. The first thing we have is in the bottom here is k equals 1. That means that we start with the first term. Whatever this number is the term that we start with. Start finding our sum of. This symbol, which is called an epsilon, that symbol means that we find the sum. So as soon as we see this, we know that we're going to find a sum from k equals 1, so starting with the first term, going up to the mth term, so that's the term that we end on, of this sequence. That means that we do C1 plus C2, so the third term, first term plus second plus third term, all the way up until we hit our M term. So each thing in this notation has meaning. First term, sum, ending on this term of this sequence. An example will help us to see that a little better. So I have this sequence, -7 plus 3n, and I'm doing my explicit, well, this is the explicit form really of my sequence. And then I'm going to start with the first term and end with the fifth term. Before I can do that, I have to find what each term is. So n equals 1. So I can say u sub 1 for n equals 1. My first term, all the way up to the fifth is what I have to find. Once I find them, I'm just going to add them all together. So plug my first one in here, starting with this. It plugs in for n. 3 times 1 is 3. -7 plus 3 gives me -4. Once I do that, I have to find my second term. So now I'm going to, instead of plugging a 1 in here, I'm going to plug a 2 into the formula. Now I'm going to plug a 2 in for n. 3 times 2 is 6. -7 plus 6 gives me -1. I can kind of tell what's going to happen here. Remember, this is an arithmetic sequence, or in arithmetic sequences, it changes by the same number each time. This is the explicit form of an arithmetic sequence, so I know that this number is going to be going up by 3 each time. I'll still do it the old-fashioned way and just plug a 3 in to make sure that this is true. So to find my third term, I plug a 3 in. 3 times 3 is 9, plus -7 gives me positive 2, sorry. So that's a positive 2. So -4, -1, positive 2. So going up by 3 each time, that's going to be 5 and 8. If I wanted to check that, just plug the 5 in here. 3 times 5 is 15, minus 7 is 8. Now I just add all these terms together. -4 plus -1 is -5. -5 plus 2, I'm not even going to do that. These two combined give me -5. That'll cancel out with this 5. So I'm just left with 2 plus 8, and my answer is 10. I'm going to work a little smarter, not harder. So I knew that my 5's a cancel, that's why I combined those two. And that's my final answer. Try this one on your own. It looks a little more complicated, but it's really the same thing. The first thing I would do on this one is, this looks like our exact explicit form that we're given. So the first thing I would do is, rather than actually put our numbers in here, I'm going to simplify this first, because I know that I can distribute this 4 to both of those. So it's going to be -3 plus 4n minus 4. Combine my like terms now. Gives me -7 plus 4n. Now it's a simplified version of this statement. So it makes it easier for me when I start plugging numbers in. Okay, so start with u sub 1. U sub 1 gives me -7 plus 4. That's -3. U sub 2 is -7 plus 4 times 2. 4 times 2 is 8. Plus -7 is 1. U sub 3, 4 times 3 is 12. Minus 7 is 5. And if you guessed it, we're going up by 4 each time. So I can just do 5 plus 4 to get that 9. Now I combine all these terms. Negative 3 plus 1, that's negative 2. Negative 2 plus 5 is 3. 3 plus 9 is 12. And that's my final answer. So don't let the Greek symbol intimidate you, because it is really just a symbol for telling us that we're doing the sum. Okay, tomorrow we're going to get into partial sums, but now I'm going to go over your homework in the next video. So it's going to be the first homework assignment that you had to do. I'm going to go over that right now.